Alright guys, so section 4 is all about rectangles. Okay, so we're just going to talk about rectangles as the first type of special parallelogram that we're going to work with. So every rectangle is a parallelogram. So the first thing you need to know about these is all of these parallelogram properties are certainly true. So you can use all of those again. Right? There's two new things we know about rectangles. Okay, the one thing you know about rectangles, the definition of a rectangle, is that it has all four angles as right angles. Okay, so when you have the right angles, you know it's a rectangle. Okay, one other thing you know about this is the diagonals are congruent. Okay, so TR and US are congruent. So that actually means that we also know that the diagonals bisect each other, so all of these are going to be the same. Okay, all of those are going to be the same. And that's really helpful for us. Right? It's also helpful because look at these triangles. Right? They turn into isosceles triangles. Right? So you're actually going to know that these base angles are congruent as well. Okay, now it looks real messy, but there's a lot of stuff you could do with that. So there's a lot of ways you can solve these problems. And let me show you how we'll do that. So in this first one, okay, we've got AE. Right, we're just going to find a whole bunch of things out about this rectangle. Each one of these is distinct, so we kind of start over on every problem. Okay, but if AE is 36 and CE is 2x minus 4, right, we know that the diagonals bisect each other because this is obviously a parallelogram because it's a rectangle. So you can just set them equal to each other and solve. 2x minus 4 equals 36. So 2x equals 40 and x equals 20. And that's all it wants us to find is x. Okay, and the next one, we've got BE and CE. Right, we actually know that these are congruent, right, because the diagonals are both congruent and they bisect each other, so all the pieces of the diagonal, the big part, the whole thing, and every piece is congruent. So we know that we could set up the equation 6y plus 2 equals 4y plus 6. So 2y equals 4 and y equals 2. Okay, that's all we have to do is find y, so we're good right there. And number 3, okay, we've got BC and AD, right? Clearly opposite sides are congruent, well, also parallel, but congruent because it's a parallelogram, so we know that we can set up this equation 5y minus 1 equals 24, 5y equals 25, and y equals 5. Okay, we're going to get a little bit tougher now. We're working with the angles, and then the last two are kind of challenge problems. So number 4, we've got measure of angle BEA is 62. Right, so this is 62 right there. They want us to find this angle right here, measure of angle BAC. Alright, so you have to use that fact that I was talking about from earlier, that this turns into an isosceles triangle. Okay, so BAC and ABD are going to be the exact same. Okay, so remember back to when we were working with isosceles triangles. In order to solve for that, alright, what we have to do is subtract 62 from 180 and then divide that in half because these two angles have to split whatever's left equally. Alright, so 180 minus 62 is 118, and if you divide that by 2, you have BAC equals 59. Right? Star that problem and remember it in case you forget how to do something like that, and I'm more than happy to work with you on some of those types of problems. Okay, so if AED number 5 is 12x, okay, that's this angle right there, and BC is 10x minus or plus 20, we know that those are going to be equal to each other because they're vertical angles. So we can set up that equation 12x equals 10x plus 20. So 2x equals 20 and x equals 10. Okay, but they want us to actually plug that back in and find the measure of angle AED. So we plug in 10 back into my 12 times x, you get 120. Okay, and number 6, this is the last regular type problem. The last two are definitely bonus type problems. So number 6, we've got BD and AC. All right, BD is the long diagonal, AC is the long diagonal. We know that the diagonals are congruent because it's a rectangle. So we set up the equation 8y minus 4 equals 7y plus 3. Hopefully you're noticing a pattern here. It's a lot of setting stuff equal to each other. Okay, and y equals 7. All right, but they want us to actually find BD, so we plug that 7 back in. You get 8 times 7 is 56 minus 4 is 52. Okay, first type problem, all right? The first type of bonus problem is one that you're going to have to end up factoring. So they are giving us these two angles, DBC and ACB. DBC and ACB. All right, so we know that those two angles have to be congruent to each other, okay, because it creates an isosceles triangle, and therefore they're congruent. So I set them equal to each other. The solving in this case is the part that's tough. Oh, not y, it's x. Minus 6 equals 10x. So remember, when you have an x squared and an x, you need to get everything to one side of the equation. So I'm going to move everything to the left side and factor to solve. Okay. I'm also going to divide everything by 2, because all three of these numbers divide by 2. That's just going to make it smaller numbers, which is easier for me to factor. So I've got 2x squared. I'm going to put the minus 5x next. All right, subtract the 10x over and then divide by 2. Minus 3 equals 0. Okay, so I need two numbers. If I know I have a 2x and an x. Okay, then I need two numbers that multiply to negative 3 and add to negative 5 when you are foiling back out. Okay, so I'm going to put my minus 3 here, my plus 1. You kind of have to guess and check here. The way you guess and check now is you FOIL this back out and you should get 2x squared. You're going to get minus 6x plus 1x, which is negative 5x, which is good. And then negative 3 times positive 1 is 3. Okay, so one of these has to be equal to 0, so 2x plus 1 equals 0, or x minus 3 equals 0, so x equals 3, or x equals negative 1/2. Okay, but only one of these is going to make sense because you couldn't plug in, you can't have a negative angle, so the negative is not going to make sense. All right, so in order to find ACB, you're going to plug the 3 back in, and you're going to get 9. 3 squared is 9, 9 times 4 is 36, 36 minus 6 is 30, so it's 30 degrees. I know that one's tough, obviously a bonus type problem. Alright, and the last one, this is the Pythagorean theorem problem, so once again, we haven't distinctly learned this yet, I'm sure you've seen it before, but if AB is 6y, BC is 8y, you know you have right angles, so you can find BD, because that's equal to AC, so all you gotta do is find AC, and that'll be the same answer. But it's going to be, let's see, so BD is going to be equal to the square root of 6y squared plus 8y squared, Pythagorean theorem. Okay, so what you're going to get is square root of 100y squared. Okay, because you get 36y squared plus 64y squared, which is 100y squared. Square root both of those, and you get 10y. Alright, so on the back, once again, we're going to focus on the coordinate plane again. Okay, so those are pretty easy problems, right, unless you get in some real complex algebra like those last two, but those would not be typical problems that you would see. Okay, what you're going to do is you're going to use those two new pieces of information here, right, to prove that something on the coordinate plane is a rectangle. Right, so if you're going to prove that something is a rectangle, you have to first prove that whatever you have is a parallelogram. That's really important. So you have to do everything we just did in the last section, right, proving that you have a parallelogram by any of the things you know about parallelograms, right, using distance, slope, and midpoint. And then you're going to either use the slope, right, use slope to show that opposite or consecutive sides are perpendicular. Okay, the whole point of that slope showing that consecutive sides are perpendicular, right, is that that's going to show you that you have right angles. Right, it's going to show you that you're going to have these right angles. You're going to intersect at 90 degrees, which obviously proves that you have a rectangle. All right, but you can only do that after you show me the opposite sides are parallel or something like that to show me that you have a parallelogram. All right, if you want to use distance formula, which is great, okay, if you do that, then what you have to do is find the distance of the diagonals, right, to show that the diagonals are congruent. Okay, so you need to show me that like BD and AC are equal to each other. Okay, so I'll show you how to do both of those. Once again, if it's tough for you to visualize, definitely draw it out. It's much easier to see. So if I'll do the slope one first, and then I'll do the distance ones at the bottom. So the slope formula, right, the nice thing about this, using the slope formula to do this, is you can show that's a parallelogram, and then show it's a rectangle, just using the exact same slopes, okay? Because you can use that to show that the opposite sides are parallel and consecutive ones are perpendicular. Okay, so find my four slopes. Slope of AB is going to be 3 minus 0 over 2 plus 3, which is 3. The slope of BC. All right, so this should come out to be perpendicular, so it should come out to negative 1/3. But we get, let's see, 5 minus 3 is 2, and 4 plus 2 is going to be 6. So 2 6 is 1/3. Alright, so I'm going to double check and make sure I didn't screw something up. 3 minus 0, 2 plus 3. Alright, so these are not perpendicular to each other, right? Because the slope is 3 and 1/3, and the slopes would have to be opposite reciprocal in order to be perpendicular. So probably not going to be a rectangle, but we'll keep going. The measure of CD. Okay, we've got 5 minus 2 is 3 over 1, which is 3, so that's good. And DA is going to be 2 over 6, which is 1/3. Okay, so it's definitely a parallelogram. Because opposite sides are parallel. Okay, so that's good. But not a rectangle. Okay, because it's not going to intersect at right angles because those are not perpendicular to each other. All right. Now, if you want to do the distance formula, the hard part about the distance formula is you actually have to find 6 distance formulas. Okay. First, you need to find all the distances of the opposite sides, right? Just like we did in the last one, to make sure we can show that it is a parallelogram, right? I'm going to skip that part because I just did it in the last video. So if you know how to do distance formula, so that shouldn't be a problem. But then after you do that, all right, so you find the distance of A to B, oops, and then the distance from B to C, distance of C to D, distance from D to A, right? Once you get all those, right, you'll show that the opposite ones are congruent. Then, yes, parallelogram. Okay. Now, to show that it's a rectangle, right, you need to find the distance of the diagonals. So you're going to find the distance from A to C and show that's equal to the distance from B to D. Okay. So if I do that, distance from A to C comes out to distance from -1 to 4 is going to be 5. So send them 0 to 0 is just 0, so the distance from A to C is just 5. Real easy. Okay. Then find the distance from B to D. Distance from 0 to 3 is 3. Then distance from 2 to -2 is 4. So you get 9 plus 16 is 25. Square root of 25 is 5. They do come out the same. Okay. So it's yes, rectangle, because diagonals congruent. And that's it.